morning students, myself Dr. Bharati Patil, working as an assistant professor physics in Maharaja Jivajirao Shinde College, Srigonda, Ahmednagar. We have started our syllabus related to TBA BSc physics, and we have started our chapter, that is chapter number 2, X-ray diffraction and other characterization techniques. During our last lecture we have finished the methods of diffraction of X-rays, and in that we have studied Lau method, then rotating crystal method and powder diffraction method. Now in today's lecture we are going to see the analysis of cubic structure by using powder method. As we know that we have preferred the powder method over the rotating crystal method, because most of the materials which are available in the world, they are made up of polycrystalline materials, and powder method is the useful method to study all such types of polycrystalline materials. Now during uh, studying the powder method, we have seen that the X-rays from the X-ray source are made monochromatic with the help of filter, and they are allowed to incident, or they are allowed to pass through the lead slits in order to make them fine, and such fine beam of X-ray is allowed to incident on a crystal under observation, which is taken in a powder form, and powder is made by grounding that crystal. Now here we have taken a cubic crystal because we want to study the cubic structure. So we have taken a cubic material in the powder form, and we have attached that, or it is placed on a hair with the help of glue, and it is suspended in a Devasherer camera. Now when the X-rays are allowed to incident on a crystal, that is cubic crystal, then what will happen? Then it will give such type of cones where the Bragg's law is fulfilled, that is 2d sin theta is equal to n lambda. We know that all n are possible, that is first order, second order, third order reflections are possible, and because of that, for each angle of incidence we are going to get a particular value of d. That is, for theta 1 we will get d1, for theta 2 we will get d2, like that, and all orders are possible, and hence we will get such type of cone whose semi-vertical angle is given by twice of the glancing angle. Here glancing angle is taken as theta 1. So semi-vertical angle becomes twice of theta 1. Like that, we have obtained the various such type of cones for different values of maxima. That is where the Bragg's condition is fulfilled. And we know that in the interior of the Devasherer camera, we have attached a photographic film, and we are getting such type of rings on it. When we develop it, due to its narrow slide, we are getting such type of symmetrical patterns on this film. And here L1 is the distance between the symmetric pattern which is obtained due to theta 1. L2 is the symmetric pattern which is obtained due to angle theta 2, and for them the d1 and d2 values are different. So like that, we have obtained such type of pattern due to powder method. Now we have to use the powder method, that is the information that we have obtained with the help of powder method, and analyze it for the cubic structure. We know that here we have used monochromatic beam of X-ray, that is lambda. Then we know that D is equal to A upon square root of h square plus k square plus L square. When we have studied Miller indices, then we have obtained one of the feature of the Miller index, that is Miller indices are used to give relation between interplanar distance and the lattice constant, that is cube h, and this is the relation between D and A, and HK are nothing but the Miller indices. So here we have obtained this relation. Also we know that we have studied Bragg's law, And from that Bragg's law, we have defined Bragg's law as 2d sine theta is equal to n lambda. What is Bragg's law? The reflected X-rays will be in phase when the path difference between them is integral multiple of lambda, and hence this is the Bragg's law. From Bragg's law, so here also we can obtain the value of d, that is interplanar distance, where d is nothing but interplanar distance. And what is A? A is nothing but cube h, because we have taken cubic structure and this formula is for cube, and HKL are nothing but the Miller indices. So here D value we have obtained as D is equal to n lambda upon 2 sine theta. So we have obtained two equations for the D, that is from Miller indices. We have obtained this relation interplanar distance and A, and here D is equal to n lambda upon 2 sine theta. It means that this side is same, left hand side is same, so one can equate the right hand side. So n lambda upon 2 sine theta, here suppose this is equation 1, this is equation 2, equating equation 1 and 2. So we have obtained n lambda upon 2 sine theta is equal to a upon square root of h square plus k square plus l square. Now in order to take out this square root, we will square on both sides. So we will obtain n square lambda square upon 4 sine square theta is equal to a square upon h square plus k square plus l square, and we have to put this in bracket. Now we will rearrange the terms. Here after this you have to squaring both sides. We have obtained this step. Now we have to rearrange the terms. What we will obtain after rearranging the terms? So I will rub this, as I have already explained you during powder diffraction method also. So after rearranging terms, we will obtain n square lambda square into h square plus k square plus l square is equal to 4 into a square into sine square theta. This term we have obtained. So now we will see that, consider, if we observe, then n square into h square plus k square plus l square, in this term all n, h, k, l, these are the integers. In this term n, h, k and l are integers. So we will replace this term n square. So put capital N is equal to n square into h square plus k square plus l square in this equation number 3. So we have to put n is equal to n square into h square plus k square plus l square in equation 3. So what we will obtain here, n into lambda square n is equal to 4a square sin square theta. Hence sin square theta upon n, sin square theta upon n, sin square theta, we will take this n here, n will become lambda square upon 4a square. So sin square theta upon n is equal to lambda square upon 4a square. Correct. So if we observe, then lambda is nothing but the wavelength of incident X-ray and a is nothing but, what is a? A is nothing but the cube edge and these are constants. These are constant. It means that lambda square upon 4a square, this value is equal to constant. And hence sin square theta upon n is equal to constant. So what we have did here, we have started the X-ray diffraction study of the cubic crystal and we have obtained the photographic or the symmetric patterns on the photographic film, and from that one can obtain the condition for maxima, that is theta 1, theta 2, theta 3 for respective values of d1, d2, d3, where d1, d2, d3 are nothing but the interplanar distances for the respective theta 1, theta 2, theta 3, where the Bragg's diffraction condition get fulfilled. Now we know that d is equal to a upon h square plus k square plus l square, where d is nothing but the interplanar distance, a is nothing but the cube edge because structure under study is having cubic structure, then h, k, l are nothing but the Miller indices. Then we also have studied the Bragg's law also. In Bragg's law is stated as 2d sin theta is equal to n lambda, where lambda is the wavelength of X-ray beam used, n is the order, then theta is the angle of diffraction or glancing angle, and d is nothing but the interplanar distance. From that also one can obtain the value of d, and it comes out as n lambda upon 2 sin theta. Now this left hand side is same, so one can equate the right hand side. Equating the right hand side, n lambda upon 2 sin theta is equal to this side. So in order to make it simple, one can square on both sides. After squaring on both sides, we have obtained n square lambda square upon 4 sin square theta is equal to a square upon the square root will get removed. So h square plus k square plus l square. Now we have to rearrange the terms. So rearranging the terms, we will obtain n square lambda square into h square plus k square plus l square is equal to 4a square sin square theta. This is equation 3rd. Now if we have observed, then n is nothing but the order, h, k, l, these are also integers. So all these components are the integers. So in this term, h, k, l are the integers. And hence we will consider a constant n in place of this term. So substituting value of n here, lambda square n is equal to 4a square into sin square theta. Now we know that sin square theta upon n is equal to lambda square upon 4a square. But if we observe this term, then lambda is constant. It is the wavelength of monochromatic X-ray beam used. A is also constant because it is a cube H which is a constant. So this term is constant. So as as lambda and A are constants, lambda square upon 4a square becomes constant. So sine square theta upon n will become constant. So we have obtained sine square theta upon n is equal to lambda square upon 4a square, and we know that lambda square upon 4a square is equal to constant. We have considered the cubic structure. We know that in case of cubic structure, when we consider a cubic structure, in case of cubic structure, the ratio of the interplanar distances d for 100 plane is to d 110 plane is to d 111 plane is given as 1 s to 1 upon root 2 s to 1 upon root 3. This shows that the given structure is cubic structure. Now one can verify this ratio by using powder diffraction method, and for that one will require the experimental data. For example, here we have considered a monochromatic beam of X-ray having its wavelength lambda as 1.3 angstrom. In order to verify this, we have considered some experimental data in which we have considered lambda value as 1.3 angstrom. And when this lambda incident on a cubic crystal, then we will get maxima at theta 1, theta 2, theta 3, etc. And for that particular D1, D2, D3 will be found out. Now here is the table which represents the values of maxima, that is theta 1 where Bragg's condition get fulfilled, theta 2 and theta 3. Now and we have obtained the values of n as 2, 3, 4, 5, 6, and we have to obtain the sine square theta upon n values for these theta 1, theta 2 and theta 3. So in order to calculate that, initially suppose theta value is given as 19.2 degree. It is the angle of incidence for which Bragg condition will get fulfilled, and we will get symmetric pattern on the photographic plate. So find out, we are in need of sine theta. So find out the value of sine theta 1. It will become 0.3289. Now here we are in need of sine square theta. Find the sine square theta value. It comes out at 0.1082. Now similarly for theta 2, we have to find out the values of sine theta 2 and sine square theta 2. Sine theta 2 comes out at 0.4651 and sine square theta 2 comes out at 0.2163. Now we have one more glancing angle for which Bragg condition gets fulfilled, and its value is 34.73 degree, and sine theta 3 comes out as 0.5697 and sine square theta 3 found as 0.3246. So we have obtained the values of theta 1, theta 2, theta 3 from that symmetric pattern, and we have considered the n value as 2, 3, 4, 5, 6, and here sine square theta upon n that we have to find out for the values of theta 1, theta 2 and theta 3. If we substitute the value of sine square theta 1, that is 0.1082 divided by n as 2, we will obtain the value as 0.0541. Similarly, by substituting value of this 0.1082 divided by 3, we will obtain this value. Then 0.1082 divided by 4, we will obtain this value. Then 0.1082 divided by 5, we will obtain this value. then 0.1082 divided by 6, we will obtain 0.0182. Like that, this column is fulfilled for the sin square theta n for respective theta 1 value. Next, we have to find out similarly the uh, sin square theta upon n values. Here, sin square theta value is here. For theta 2 is 0.2163. We have to divide it first by 2. We will obtain this value. Taking this value divided by 3, we will obtain this value. Then again 0.2163 divided by 4, we will obtain this value. 0.2163 divided by 5, we will obtain this value. And lastly 0.2163, that is sin square theta 2 divided by n 6 will give us 0.0361 for theta 2. Then for theta 3, similarly we have to substitute the values of sin square theta 3 and n values. Initially, considering 0.3246 divided by 2, we will obtain 0.1623. Then 0.3246 divided by 3, we will obtain 0.1082. Then by 4, we will obtain 0.0812. Again, we have to divide this term by 5, we will obtain this value. Again, you have to divide this value by 6, we will obtain this value. And we know that we have obtained that sin square theta upon n is equal to lambda square upon 4a square, and this value is constant. So, if we observe this table, then sin square theta upon n should be constant. For theta 1, if you observe, for theta 1, theta 2, theta 3, there is one value which is constant, and by observing we will find that that value is 0.0541. This factor is constant for theta 1, theta 2 and theta 3. So we have obtained the value sin square theta upon n is equal to lambda square upon 4a square, and it is obtained as 0.0541. Its value is 0.0541. This is the value of sin square theta upon n. So here, by using this equation or by using this information, one can find out the value of A, which is the characteristic of that cubic material. So here, instead of now considering this, we will solve this and we will obtain lambda square upon 4a square is equal to 0.0541, and hence a square will become a square, taking a square here, lambda square upon 4 into 0.0541. We know that we have initially taken the value of lambda as 1.3 angstrom. We have taken the value of monochromatic X-ray beam as 1.3 angstrom, and hence we will substitute it here 1.3 angstrom square divided by 4 into 0.0541, and it gives us a square value as 7.81 and a value as 2.79 angstrom. So we have obtained the value of A as 2.79 angstrom, and we know that A is nothing but the cube edge. If we draw a cube like this, then this value is A. So we have obtained the value of A with the help of the experimental data that we have considered. Now by using this A value, one can find out the value of D, that is interplanar distance. So what is the formula for D? We know that interplanar distance is given by A upon square root of h square plus k square plus l square. Now we have seen that in case of cubic structure, the D, that is interplanar distance for the set of parallel planes 1 0 0 is to D 1 1 0 and D 1 1 1. So we have to calculate the value of D for 1 0 0 plane, then for 1 1 0 plane and for 1 1 1 plane. So by substituting the value of A here, initially we will calculate the value of D for 1 0 0 plane. So in order to calculate this, we have to substitute the value of A. That is, we have calculated it as 2.79 divided by 1 0 0. It means that 1 square plus 0 square plus 0 square. So it comes out as 2.79 upon square root of 1. That is 2.79 angstrom. So D100 we have obtained as 2.79 angstrom. Now we have to calculate the value. Now we have to calculate the value of D110 plane for D110 plane. Again we have to substitute the value of A as 2.79 and square root of 1 square plus 1 square plus 0 square. It means that 2.79 upon square root of 2, and it gives us the value as 1.973. 1.973 angstrom. This is the interplanar distance value for the set of parallel planes 1 1 0. Similarly, we have to find out the value of D for 1 1 1 plane. In order to calculate this value, again we have to substitute the value of A that we have calculated. Then again h square, 1 square, k square, 1 square plus l square, 1 square. It gives us 2.79 upon root 3, and its value comes out as upon root 3, it will gives us 1.61 angstrom. Now what we have to verify? We have to verify that in case of cubic structure, the ratios of the interplanar distances for the set of parallel planes 1 0 0 is to 1 1 0 is to 1 1 1. Now in order to get this ratio, what we have to do? We have obtained the value of D100. Now we have to divide this value by 2.79, this value by 2.79 and this value by 2.79. After dividing this value by 2.79, we are getting, it means that D100 D110 D111. So if we divide this value by 2.79, we will obtain 1. If we divide this value by 2.79, we will obtain 1 upon root 2. And after dividing this value by 2.79, we will obtain the value as 1 upon root 3. So we have verified that in case of cubic structure, this condition is fulfilled. That is, we have confirmed the Bragg's law, application of Bragg's law in case of cubic crystals. So here what we did, we have taken one example where we have considered the lambda value as 1.3 angstrom. Then we have obtained the relation sin square theta upon n is equal to lambda square upon 4a square. We have calculated the values of sin square theta upon n for various maxima, that is theta 1, theta 2, theta 3. and we have tabulate it like this. After observing these values, we have obtained the constant value. It means that we have obtained the value of lambda square upon 4a square as 0.04541. By using this information, one can get the value of a, that is cube age or interplanar distance also. So initially we will calculate a value, and after that we will calculate the d value. We can calculate the d value. So initially we have calculated the a value from this, and a value comes out as 2.79 angstrom. Then by substituting this value in formula, d is equal to a upon square root of x square plus k square plus l square for various d, that is for set of parallel planes d100 whose HKL plane is 100. We have obtained the value as 2.79 angstrom. Then for HKL planes 110, the value is obtained as 1.973 angstrom. Then for set of parallel planes 111, the value is obtained as 1.61 angstrom. So if we take the ratio of D, that is interplanar distances for these planes 100, 110 and 111, we have obtained the relation as 1 as to 1 upon root 2 to 1 upon root 3, and in order to get this, we have divide this value by 2.79, divide this value by 2.79 and divide this value by 2.79, and we have obtained this relation, which is nothing but the verification of this statement. Now for first order Bragg reflection, we know that Bragg's law is given as 2d sine theta is equal to n lambda. For first order Bragg reflection, n value will become 1. So here theta 1, 2d sine theta 1 is equal to lambda. Similarly, in case of for sine theta 2, this value becomes theta 2 is equal to lambda. 2d sine theta 3, that is for third order maxima, where the theta value is theta 3 is equal to lambda. For first order, that is we have to substitute the value of n as 1, and theta 1, theta 2, theta 3, these are nothing but the glancing angles. So here d1 as to d2 as to d3. So here d1 as to d2 as to d3 is obtained as 1 upon sine theta 1 as to 1 upon sine theta 2 as to 1 upon sine theta 3. Then we know that we have obtained the value of sine theta 1. What is the value of sine theta 1? From this table, we have obtained the value of sine theta 1 as 0.1 upon 0.3289 as to sine theta 2. 1 upon sine theta value is 0.4651 and sine theta 3 value is 1 upon 0.5697. So we have made the use of this table, and we have substituted the values of sine theta 1, sine theta 2 and sine theta 3 in this equation, and we have obtained the d1 as to d2 as to d3. If we solve this, then this will come out as 1 as to 0.716 as to 0.58, and this is nothing but 1 as to, if we divide it back, then 1 is to 1 upon root 2 is to 1 upon root 3. This value is nothing but 1 is to 1 upon root 2 is to 1 upon root 3. So planar distances for here 1 means nothing but 1 0 0 plane, 2 is nothing but for 1 1 0 plane, and 3 is nothing for 1 1 1 plane, and hence we have obtained the ratio as 1 is to 1 upon root 2 as to 1 upon root 3, and we know that in case of cubic structure the condition or the relation between these planes is given by this. So this confirms the crystal structure of given crystal is cubic crystal, means the crystal which is under observation is having cubic structure. So what we did, we have used the Bragg's law, then we have taken the condition for first order Bragg's diffraction, and we have substituted the value of n as 1. Then for respective values of theta 1, theta 2, theta 3, we have considered d1, d2, d3. d1 is nothing but it is representing the plane 1 0 0, 2 is nothing but 1 1 0, and 3 is nothing but 1 1 1. So d1 is to d2 is to d3 comes out as 1 upon sin theta 1 is to 1 upon sin theta 2 is to 1 upon sin theta 3. By making use of this table, we have substituted the values of sin theta 1, sin theta 2 and sin theta 3, and we have obtained this ratio as 1 is to 1 upon root 2 is to 1 upon root 3, and this is nothing but this represents the cubic structure. So here we have used the power diffraction method to analyze the crystal structure of cubic structure. Thank you.